Hello. Hey. Thank you for being here. Nice to meet you. My name is Todor, as you just heard. They pronounced it almost correctly. I am here to talk to you about Nuke. You're not going to see it here, but I guess you read it on the agenda already. But before we go in deep dive into it and just talk about it, I will do a brief introduction, as you've heard in all different sessions already. So my name is Todor Todorov. I've been a .NET developer for the last 15 years. Although I'm a little bit more DevOps oriented in the past couple of years, I'm not a DevOps engineer because there's no such thing. I'm a clean code fanatic. I will fight to the death about that last tab there that you put. I don't like that. I'm trying to be a speaker, as you might have noticed. And I'm a father of 3 boys, so please send your hugs and wishes. And I'm a karaoke enthusiast, which means I like to yell, as you're about to hear now. But why are you here today? Why am I here today? What are we going to talk about? Well, let me ask you a question. How do we do builds nowadays? I suppose all of you are doing that, or at least some of you, or at least you've seen how they are being done. And having in mind how things are happening in all the big platforms and providers currently, we know that YAML is king, right? So either if you are in Azure DevOps or GitHub Actions or GitLab or TeamCity or whatever, usually it all starts with YAML. And how many of you are using YAML for your build definitions? I suppose everybody? Is anybody using MSBuild? Okay, really? Still? As scripts? MSBuild scripts, right? No? Okay, doesn't matter. So yeah, YAML. And we're all used to YAML, kind of, because it's been there for quite some time. So you might ask me, so what's the problem with YAML? Why we are even talking about that at the moment? What can Nuke do for me better than YAML? And I will give you a little example. So this right here is my repository for an awesome application that I've written. It's called Awesome App. It doesn't do much, but it was created as a showcase for what Nuke can do for you. It's in GitHub. You can go check it out afterwards. This is the action workflow, GitHub action workflow for building it. You're not seeing anything at the moment, but I will do a little bit of that. So I'm not sure. Do you see where the problem with that definition is? Can you see it from there? I'm sure you see it, really? Man, that's because you're in front. All right, nobody else can see it in the back, but I can zoom it even more because this is the only way that you'll be able to see it. There it is, this little red squiggly here, right? How many times you've seen that? How many times? No, let me rephrase that question. How many times you did not see that before you check in and you commit your build definition? And you just wait, right? You've written your YAML, you push it to the repository, and now you wait. What happens? You're waiting for the build to roll. You're blocking agents for execution. You're waiting 10, 5, 15 minutes, whatever. And then, boom, it breaks, right? It says, well, invalid workflow, blah, 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 blah. So you've wasted time, you've wasted money, you've wasted resources just to figure out that this one little squiggly here is preventing you from doing that. Oh, did I show it? Oh, okay, yeah. So why this is a problem? Well, you can't see it right now, but if we take that little line here and we enhance it, this is when we see where the problem is, right? It's that this width here has one more space next to this width here. This is how YAML works, right? It's intent-based. And I still cannot fathom the fact that they are calling this human readable. It might be human writable, but it's not human readable at all. And noticing things like that is really hard. And because of that, I can say, dear YAML, I hate you. I hate you so much that I really want to get rid of you in all ways possible. And what is even worse when you're using YAML for your build definition is that all the different platforms, they have their different schema and their different style of what they put in YAML, right? I see somebody nodding there. You know what I mean, sir, right? Yeah. So everybody one platform calls it tasks, the other platform calls it targets, the other platform calls it whatever, unicorns and dragons. So let me ask you another question. Have you ever had to migrate your build definitions from one platform to another? So let's say you have tons of that. Anybody done that? Maybe because it's nearly impossible to do, right? You have to rewrite them all. So for example, if you live in GitHub and you have all your definitions there, and then the evil Microsoft bought them, and you're like, fuck it, I'm not going to be there anymore. I want to go to GitLab. Yeah, but GitLab doesn't really work with GitHub definitions and GitHub actions. So you gotta create them all from the beginning. Another reason for me to really hate YAML as a way to define your build pipelines. And you might ask at this point, so okay, is that the only problem that is happening with YAML? Okay, it's not a very good way of defining stuff. It's really problem. Well, it turns out it's really not the only problem. There are many problems with that approach. So on-prem, how do you test that on your local computer? You can't. You wait for the agent to take some time to take resources to validate it for you. IDE support is really bad. I know that there are attempts in order to make it better, but come on. And libraries, extensibility, build sharing, reusability. How do you share builds with YAML? You copy-paste text files, right? It's not something that is more sustainable, more easy to reuse between different pipelines, right? So that's why I'm going to talk to you about Nuke. Nuke, and I'm not going to try to explain it. I'm going to shamelessly steal their explanation from their website. So Nuke is a cross-platform build automation solution using C# as DSL. Yeah, I know you might not be .NET developers, but the thing that it uses C# doesn't mean it is intended to build just C# and .NET stuff. You can build anything with it. Yes, your pipeline will be written in C#, but you can do whatever you want. And C#, it is approached to embrace existing IDE tooling because it's a compiled language. The compilers on all of the great tools like Visual Studio Rider, Visual Studio Code, they just work. They help you. You can debug. And a state where everyone in the team is able to change the build. Because usually, one of the problems for separation of developer teams and DevOps teams or operation teams is because developers don't know pipelines. They know code, right? They know how to write code. Well, this is code. They know how to do that. They know how to reuse libraries. They know how to write code. So they shouldn't have an excuse when you ask them, can you fix that pipeline? Oh, I don't understand YAML, sorry. Well, you understand C#, right? Pretending you're a C# developer. So you might ask yourself what I have to do with, how am I related to Nuke? I'm not. I just like it. I just love it. It's an awesome thing, and I love sharing things like that. The creator of Nuke is this handsome fellow. His name is Matthias. It's an open source, free project, MIT license, everything. He's a very, very good developer, and his vision for how this thing is done is really incredible. Again, you might ask yourself, how am I related? Well, I helped. I'm part of the contributors. This is me here, yeah, on the README, yeah. Well, it's only one commit, but it's something, right? I helped, right? I mean, I tried, but I will do more. I promise, I will do more. So yeah, let's talk about it. What is Nuke? Well, it's very simple. It's nothing more than just a console application part of your solution, part of your project, part of your repository. So what you do is just add it to the main solution that hosts all of the other files if your repository is about .NET. If it's not about .NET, it's just one more project in that repository. But it's so much more than that. It also has a global tool. Global tool, for those who are not coming from the .NET world, are CLI tools redistributed using NuGet packages. It's very powerful. You can install them with one command. It's something like npm install, but it's called NuGet install, tool install, whatever. Yeah, extensive libraries. It has extensive libraries for different predefined things that you will be using in your pipelines, helper libraries, CLI tool support. I will show you that in a minute. It's awesome how it's working. Fluent syntax, I will show you that also. I'm sure many of you know what it means. CI system integration, this is the cherry on the cake. I will show you that later. Path handling, solutions and projects, stack and teams notifications, you name it, and many more things. So a very rich subset of libraries that can help you really boost your pipeline defining and working with. So let me do a quick explanation of how things work. So how do you set up the global tool? How do you set up your definition? So let's say that you have already prepared your repository, you have your projects there, and then you just install with one command the global tool by Nuke. You don't have to do that. You can do that manually if you want, because it's just another console application. But they give you this really awesome tool that can do it for you. So you just install it and you call Nuke setup in the root repository, in the root folder of your repository. So when you call Nuke setup, it starts a little bit of a console wizard, if you will, that will ask you some questions in order to set up everything for you, in order to set up that console application. So it's going to ask you, how do you want to name your project? By default, it's _build. Where is your solution? It finds your, well, the build is going to locate it with which folder? Folder build. Where is your solution and version of Nuke that you want to use? It's going, so you're not going to see that because I was not prepared for this thing here, but yeah, let me go up a little bit more. So it can get you started with a basic build, which means it will populate some, they call it targets, which are steps in your build pipeline. And it's going to ask you where your stuff is located, like SRC folder, output folder for artifacts, where your tests are going to be in that repository, things like that. So it's doing all of that for you so that it gives you a skeleton for your build pipeline definition, right? And let's talk about why this is, how this can affect your how this can affect the evolution of your build. Because, you know, usually pipelines are a tree of dependencies. The steps that you have are different for different use cases that you want to use. Because for one use case, you just restore or install packages, compile, run some unit test, integration test, whatever. You go in that route. But there's another branch where you want to just build a Docker image and maybe push the container. You don't need to do all of that anymore because it's being done inside the Docker image. Usually with YAML, you would create two different build definitions for that. You would create two different YAML files, one for this branch and one for this branch. There are some ways of splitting that in one YAML file, but usually people don't do that. Here, you can put it all in one place, and you just define the dependencies between your steps, and it does that for you. So they call them targets, the steps in your build, which are basically just properties of type target. So restore is a property of type target that you pass some function, some lambda in the execute part to tell it what to do. And how you structure those is you start, for example, with a clean one, which cleans up before the next build starts what is left over from the last one. So you just create, and you say before restore, because you're going to create a restore target also. And the cool thing about that here is all of those things, they are not just text, they are compiled properties. So you can navigate to definition, you can refactor, you can change all of that without Control F, search for that string, replace, oh, I replaced the wrong one, and things like that, because the IDEs know how to work with that, right? So you gotta restore, and the before one clearly says that if you run those two together, it will run the clean one before the restore one. And then you have a compile one, which depends on restore one, which means it will structure it that if I run compile, it will say, okay, it depends on restore, I will run restore first. And this is how you build that, that cool tree of dependencies in your steps of the build. And you're seeing here those ... stuff. This is the Fluent API or Fluent syntax or whatever. So this is not something new. It was defined quite some time ago, but Eric Evans and Martin Fowler. If you don't know who they are, I suggest you do. They kind of matter. So they have defined this Fluent interface thing, which is really a way of chaining your methods so that they can be human readable, not like YAML. So that you can create something like that. I want to run .NET test, and I'm setting up the configuration for that by just chaining methods directly on that previous one, because each of those methods is getting, it's an extension method which is getting the thing that you're currently changing. In this way, it's the configuration for .NET test, and returning it, so the next one can get it as a parameter and return it. And this is how it works. And what things like that is doing, I'm not going to go into details because it is more of a deep dive thing. But what this thing is doing is generally creating a CLI call. It's wrapping a CLI call. Because most of the things that your pipelines are doing, they are just running some other CLI tools, right? They are running either npm install or .NET restore or whatever, or Maven run, you name it. So you have those classes which are created by Nuke for you, and you just call those methods, and this will translate to that .NET executable restore my solution, that code here. And what that is are the CLI tools. So now we're getting to something cool. This is the notation how Nuke does things. It has many already predefined libraries and methods for common tools that we are using in our pipelines. This is some of them, most of them. And what that means is they are really generated based on the actual help and parameters that you can find for that tools online. So for example, if I want to call Docker build, the set file method is directly showing me in the IDE when I hover here my mouse, it's showing me that thing here, name of the Docker, blah, 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 which is directly taken from the -f file on the Docker CLI reference. So it's the same thing. So you know it. You worked with those tools, and this makes you feel at home. Other ways of working with executables, you can locate define an executable in your environment variable path. So, for example, yeah, I said path executable Docker, and Nuke will automatically map that executable to this property, which is of type tool, and I just can call Docker invoke or just Docker with some string, and it will invoke it in the other way. This is mostly needed for tools that still don't have support in Nuke out of the box, that don't have generated methods for them. So you can call whatever you want. So you can call a path variable one, you can call one which is an absolute or relative path somewhere on your build system or whatever, or even in part of a NuGet package, because it can be distributed as a NuGet package. And what you can do is something like that. I'm not sure if you're seeing that. Let me just... So I can say Docker, and I'm just passing this string, which is concatenated with run it image name command, which I have created here for something, and this will run Docker run it alpine sh. Boom. And now I will show you something more cool. The CI system integration. prepare yourself to be blown away. Because now you'll ask me, okay, Todor, everything is cool. We have this cool framework. It's a console application. We need to call it somehow, right? We still need to write the YAML file, right? Because that's how the systems work. In order for GitHub Actions to run my Nuke console application, it needs to invoke it somehow. Somebody needs to tell GitHub, run that. Well, Nuke got you covered for that. It has already prepared attributes for the 4 main ones: GitHub Actions, TeamCity, Azure DevOps, and I forgot which one was the 4th one. So you just put that attribute on top of your build class. You're not seeing very well, but this is where your build class starts. Your build console application starts. You just put that with some configuration, and boom, your YAML file is automatically generated inside your repository so that GitHub Action can run your build. You don't have to do that. You don't have to write, this is generated for me. I'm not doing anything here. I don't know how it works. I'm going to show you that just right now in a very cool demo. So, okay, duplicate. So what you're seeing here, let me open up this thing. Let me open up this one. So this is my, do you see it? Do you see it? No. Let me just change it a little bit. Okay, no. Right, light, is that better? No. Yeah, I was not prepared for such a light room. I was thinking it would be, maybe that's better. Okay, so this is my Nuke definition, and here is where my build class is starting. And on top of my build class, I have GitHub Actions, right? As I showed you earlier. And what this does is when I run Nuke locally on my machine, it automatically generates this YAML file. There it is. And what it does is just create a task in GitHub Actions that will run your build, your Nuke build. And I just push that thing to my repository, and boom, I have an action which is running. There it is. And this is something that I didn't write any YAML for it. It just works. And I specified I wanted to run in 3 environments. I have all of those environments. I have the stuff. And here, if I expand this, you can see the output of the command that was running my Nuke. And here are the targets, the different steps that my Nuke definition has. The restore one, the compile one, the test one. And since Nuke knows this is GitHub Actions, it is passing the command line parameters in a way that GitHub understands in its UI so that you can collapse and uncollapse, things like that. So you can see the output of all of your build stuff. And of course, a very nice summary at the end with past tests, whatever. I'll tell you something even cooler. So I have this one here, but I have one more. Next to that argument, I have put another argument. And boom, I have the same thing for Azure DevOps. So my repository is building the same build definition that I've written without me writing any YAML on both platforms simultaneously. And it is the same thing. And it is the same thing that I will run locally on my machine. I can debug it, and I can see why it's not running or what is happening there. How cool is that? Okay. So, another cool thing is that after you spend some time, your build tree becomes larger, right? And dependencies between it start to look not so easy to understand. Well, Nuke got you covered also. If you run the Nuke plan command, it will output an HTML version of your current build, how you defined it in Nuke. The dependencies between the different targets, how they look like, and even more, I can again show you. Give me a second. I can show you a bigger one. This is the one for the Nuke repository. Because mine in the Awesome App one is quite simple. This is what they have in there. And if I hover, I can see the paths that are going to come. If I want to install, okay, it's going to pass through here, starting from here. If I'm going to publish, it will do all of those. And this interactive thing is just an HTML generated on my machine by Nuke. I can show it, I can see it, I can do whatever I want with it, right? And the next cool thing that Nuke also has, which I find it very, very, very cool, is a division operator magic. So when you're working with builds, you need to work with a lot of folders and files, right? You need to know the locations of those. You need to move one thing from another. You need to populate that directory with some things. You need to delete that file, whatever. This is why they introduced a class called absolute path. They also have a relative path, but this one is more cool. So the absolute path works by overriding the division operator so that you can concatenate paths the same way that you might do it with path combine or something like that. But again, in a referenceable, debuggable way, because those are properties that you can navigate to and you can easily work with. So root directory is one that comes out of the box from Nuke, which is mapped automatically when you start your build to the root directory of your Git repository or yeah, whatever. So if I do like that /src, this will assign an absolute path to the source directory here. And it knows on which operating system you're doing it, so it will do the appropriate string concatenation. And so this here, root directory, on Windows will look like that. On Linux, it will look like that, the string behind it. And last but not least, they have IDE extension support. So they have extensions for Rider, for Visual Studio Code. And what you can do with those extensions, you don't really need them, but they are cool, and I will show you quickly what they can do. Is that when you open your build definition, it finds out where you have targets and puts this little Nuke icon next to it. So I can easily click it and I say, okay, I want to run that, to debug that, or to run it without dependencies or whatever, and I can just put a breakpoint here, and I can debug it. Just give it a second, my computer is a little bit slow. I'm not sure if you can see that, but it's running down here in the console, and boom, I'm hitting a breakpoint here. And I can try, and I can see, well, I have here a Docker file. All right, this is the Docker file here. This is the path for my Docker file. Everything, oh, I forgot something here. I can fix it before pushing it and seeing that it doesn't work. All of that thanks to compiled languages, right? So, before I go, I want really to take this moment to remind you again that Nuke is an open source project. Everybody can contribute, we are open to pull requests. If you find something that you need and you want, please go check it out. You can write a fix yourself, you can write a feature yourself, you can become one of the little circles on the README file, like me. Also, it's using GitHub sponsorship, so you can sponsor the project if you want. I'm not getting any money of that. It all goes to the creator, who is maintaining it full-time almost. But yeah, that will help him do that. There are many companies, there are many GitHub users that are sponsoring him because the platform is awesome. And with that, I want to thank you. You can find me on all of those places. You can take a photo of that QR. It has all the links that you can find me. And that's it from me and for Nuke. Thank you for being here. Thank you. If you have any questions, I'm up for it. If you don't want to ask them now, I'll be here for an hour or more, an hour and a half until the conference is over. You can find me. I'll be running around. I'm really open to anything. Sorry? No, I didn't mention that, but yeah, you can make unit tests for your build definition. This is just so crazy to fathom, right? Unit testing your build definition. You can do that, no problem. Because it's just classes, it's just code that you can unit test. All right, thank you.